From hundreds of miles up in space, we have satellites constantly watching our planet. But they face this surprisingly tricky challenge, a real case of mistaken identity that has huge consequences for every single one of us down here on Earth. Okay, so take a look at this. At first glance, it seems simple, right? But can you tell me with 100% certainty what's a cloud and what's a blanket of snow on the ground? It's actually a lot harder than it looks. And for scientists, getting this right is absolutely critical. And here's the problem. From a satellite's point of view, snow and clouds are practically twins. They're both bright white, and they both bounce a ton of sunlight back into space. So if you're just looking at a standard picture, they are incredibly difficult to tell apart. So you're probably thinking, okay, a bit of snow, a few clouds, what's the big deal? Well, it turns out solving this puzzle is a massive deal. The answer that's hidden in these fuzzy white pixels directly impacts our ability to manage the most precious resource we have, fresh water. I mean, think about it. Being able to accurately measure snow on the ground, what scientists call snowpack, is essential for so many things. We're talking about managing the drinking water for millions of people. It's about predicting potentially devastating floods when all that snow starts to melt. It's about planning for droughts and, of course, tracking the long-term effects of climate change. It all starts with one simple question. How much snow is actually down there? And this is where it gets really serious. Getting this wrong isn't just some abstract problem for scientists. It leads to very real-world risks. If you miscalculate the snowpack, you could end up with major water shortages, or, on the flip side, be completely unprepared for catastrophic flooding. This is a critical piece of the puzzle for keeping communities safe and sustainable. For years, people have tried to crack this nut with all sorts of methods, but with pretty mixed results. But now, things are changing. A new AI model is stepping onto the scene, and it's proving it can see through all that white confusion with what you could almost call supervision. The hero of our story is a specially modified AI called MDeepLab v3+. Yeah, I know it's a mouthful, but what this powerful tool can do is, frankly, amazing. It's designed to solve this one specific problem that has stumped experts for decades. So how does it work? Well, it uses a cool technique called semantic segmentation. The easiest way to wrap your head around it is to imagine a coloring by numbers picture, but for a super smart computer. The AI looks at a satellite image and meticulously color codes every single pixel, labeling it as either snow, cloud, or just background. The whole process is actually pretty straightforward. First, the AI gets fed a special kind of satellite image, one that contains light information our own eyes can't see. Then it analyzes every pixel across all these different light bands. It makes a decision for each one, and finally, it spits out this incredibly detailed and super useful map. But what makes this particular AI so much better than everything that came before it? Well, it really boils down to two key innovations. This is the model's secret sauce. All right, secret number one is that this AI has a kind of superpower. It can see light that is completely invisible to you and me. So check this out. In the light we can see, like the blue and red bands, snow and clouds look pretty much the same. They both reflect a lot of light. But here's the trick. The AI looks at a special band called shortwave infrared, or SWIR. And in this light, the difference is like night and day. Snow actually absorbs this light, so it looks dark. But clouds, they reflect it, so they stay bright. For the AI, that's the dead giveaway. It's the ultimate tell. The second ingredient in the secret sauce isn't about what the AI sees, but how it sees it. The researchers basically gave the model what you could call enhanced peripheral vision. So the technical term here is increasing the dilation rate. But what that really means is, instead of just staring at tiny little clusters of pixels all by themselves, the AI is programmed to kind of zoom out and look at a much bigger area all at once. This gives it context. It can ask itself, is this bright patch sitting on a mountain range where snow should be, or is it just floating in the sky? Seeing that bigger picture helps it make much smarter, much more accurate decisions. So, the theory sounds fantastic, right? But the real question is, does it actually work any better? Well, the researchers put it to the test, pitting it head-to-head against older, more established models. And wow, the difference is pretty stark. You can see how older models, like one called UNet, they tend to struggle. They miss thin, patchy snow, or they get confused around the edges of clouds. But the new MDeepLab v3+ model, it's way more precise.
It consistently nails those fine details and just makes way fewer mistakes.
And the numbers, well, the numbers tell the exact same story. An older model gets about 90% accuracy. The more advanced unit model does better, getting close to 94%, but this new model, MDeepLab v3+, it takes a significant leap forward,
hitting an overall accuracy of 96.78%. Now, that jump of almost 3% might not sound like a lot, but in the world of remote sensing, that is a massive improvement. It really is a genuine breakthrough in how we monitor our planet.
So, let's bring it all back home. What does this super technical AI achievement actually mean for us? Well, it means we're heading towards a future that's a lot clearer and a planet that's a lot better managed. At the end of the day, this isn't just about making better maps. This breakthrough means more reliable water planning for our cities and our farms. It gives us better tools to predict and prepare for dangerous floods. And it gives climate scientists the cleaner, more accurate data they desperately need to understand our rapidly changing world.
The researchers who built it sum it up perfectly. They call it a robust and domain-adapted approach, which is just a scientific way of saying they've found a much more reliable way to see through the clouds and understand what's really happening on the ground. And that really leaves us with one final big question. This technology solved a problem that's been bugging climate science for decades. It really makes you wonder, what other huge, maybe even seemingly impossible global challenges could we solve if we teach AI to see our world not just as we do, but with a vision that goes far beyond our own?